Okay, we just finished up creating our first regression equation, but now we need to dive a little deeper into variation. So what we're going to do is we're going to discuss decomposing variation. Now I'll just give a disclaimer right now. We're going to discuss all of this right here, but we're going to do all of this in Excel. So we're going to take care of all of the sum of squared residuals in Excel. But it's an important thing to discuss, so hopefully you listen in and can get an idea as to where variation in our data is coming from. That's my goal here. But ultimately, we're going to just be creating the tables in Excel, and can you properly just identify different aspects from our table so we can calculate all of the necessary things to perform regression analysis. So variation. So we have this y variable, our dependent variable, and it's going to vary. And recall that we have variance and standard deviation as measures for variation in a data set. So we're talking about a response variable. So our response variable y. Let's talk about y. We can decompose its total variation into two sources. So if you recall, when we calculate variance, we're calculating the distance between any given value and its average. So when we think about the total variation in y, it's just the difference between that value and the mean value for y. That is total variation. And what we're saying is we can break it up into these two sources. So the first is the difference between our predicted value and the overall average. So we're going to do our predicted value of y minus the overall average in y. And then the other part of the variation is the actual value of y minus the predicted value of y. So we have this total variation in y, and we're breaking it into two parts, from predicted to the average, and our actual to our predicted. So if we sum these things, so let's just sum over the entire data set and square them. Recall that we always square distance because if we sum up the total distance, it'll just come out to 0. And so we have sum from I equals 1 to n, and we're just summing up the total variation. So the difference from yi and its average, and we're squaring that. So this is just the formula for variance. So hopefully that looks fairly familiar. And then we're just doing the same thing for the others. First, we square that difference from above, and then we're going to sum up over the whole data set. And that is our total variation in the data. So what we're going to say is that it's total variation, think variance. Part of it is explained. What is it explained by? Well, it's explained by our regression, right? And our regression is our estimated value of y. So the explained part of the variation is just the difference between our estimated value and the overall average. By contrast, we then have our unexplained variation, or our residuals, which is the difference between our actual value of y and our estimated value of y. So that's what we're doing here. We have this total amount of variation in our response variable y. Part of it is explained by the regression, part of it is not. So when we think about the sum of squares, we're going to call total variation the sum of squares total. That terminology should be familiar from the ANOVA chapter. It's broken into two pieces. Sum of squares from the regression. So regression is what's doing the explaining. And sum of squares error. Error is our residuals. It's what we can't explain, right? Our regression is never going to be perfect. There's going to be differences, and therefore we're going to have that unexplained portion of our variation. So now I just want to visualize these things. So like I said, this is all going to be done in Excel, so don't worry about having to calculate these things by hand. So let's just visualize all of this. So total variation, again, this is yi minus y bar. So this is the same scatter plot we've looked at several times so far in this chapter. Recall the average in miles per gallon was 20.09 miles per gallon. So I drew this line where the average is. So our total variation is yi minus y bar. So to visualize this, I'll use a different color. The difference then is just all of it's these distances. It's our actual value of y minus our average value of y. So all of these. So technically I would draw lines from every blue dot to the red line, but that would take a while. But this is the distance we're talking about. Distance from every actual value of y and the overall average of y. So we're summing up all of these yellow orangish distances to get our total variation. But then our explained variation, recall it, our explained is our actual value of y minus the overall average. So when we think about what's actually happening with the explained variation, well, it's just the difference between the regression line and the average. So at every data point, essentially, we're just taking the difference between our regression line and the overall average. So all of these distances would represent our explained variation. And then finally, unexplained variation, which is our actual value of y minus our estimated value of y. And so that's going to be our residual. So how far is any given value away from our regression line? These are our errors. This is how much we are off by. So that is how we represent it. So these are our two sources of variation. So total, they can be decomposed into explained and unexplained. And these are important concepts as we move forward in terms of determining what is actually statistically significant in our regression.